Hello world, Paul Whittakin back with Guess Who, the Universal Law of Numbers. And one thing I want to do is I want to make a clarification or correct myself from something I said yesterday, and I just want to follow up with where I left off yesterday. Where I left off yesterday was I was pointing out the differences between the numbers in the code, and you can go between this number and this number, this number and this number. You can go between this number and this number, this number and this number, this number and this, any combination of the numbers, but you're going to come up with the code and the interesting results that basically simplify math into its basic form and understanding. Now, I give this thing names. One name I'm going to give it, a new name is perfect. Okay, because some of us, well, we've all heard this expression that there's nothing perfect in life, and as it turns out, that's not true, because this is absolutely perfect. So that might give you some pause for thought. I called it the seeds and the roots of the tree of mathematics and all of the branches, and that's what it is. It's basically the core of all mathematics and understanding. So today, for my purposes, I'm just going to call it mathematics. It's worthy of that name, and it's very important to understand that, because we often confuse the fact that, like reducing numbers, you reduce fractions, and when somebody starts reducing numbers, it's considered by some to have no mathematical validity. But I would have to tell you, unfortunately, they missed the entire point of it, because it's entirely valid. It explains how mathematics and the world of numbers work. So anyway, here we have a sheet that I brought out in the previous one, and I hope you can see that. But anyway, there was references made to Euler's number, the natural logarithm, e, the unique number whose natural logarithm is 1. It's a universal number. It's considered irrational. But as I spoke yesterday, I don't consider any numbers irrational. Only people can be irrational, and people can have difficulty understanding numbers. They have their own way of communicating, and sometimes they hide behind a cloak. But if you're able to remove that cloak, you're able to see clearly, the numbers that are hiding behind in the shadows. And that is a very, it's a very, very important lesson in the subject of life. And mathematics, besides describing the natural sciences, also has a way of describing all areas of learning, and especially the area of life. So I want to point that out. So anyway, I referred to Euler's number as Bernoulli's number. They're not exactly the same. I apologize for that. There's a relationship between the two. It's not important. It's not the messenger. It's the message. It's the number that's the universal thing. Okay, so another thing I pointed out was, what I attempt to demonstrate is how all mathematics is based on the 369 code. And what we have here is the 369 code in its perfect form, and from that reference point you can study mathematics and understand that it's all 369. And one of the things I did yesterday was I pointed out the difference between these numbers. It might be 1 and 4, and go down this row. It might be 1 and 9, go down this row. It might be the difference between these numbers going down this row, the difference between these numbers in the 7 row and the 7 row. And what you do is you always get the numbers, the codes reappearing. And so I made this claim that these numbers are all related. And I attempt to demonstrate that. Now, with the Fibonacci code, it adds up to 54 if we add the first 9 numbers. But if you consider this 4 and you consider this a 3, this number down here will be 27. All of these numbers, 39, 36, 39, 27, 27, and 51, will all add up to 90 or 30, or 60, excuse me, if you compare them to the rows going across in the periodic table, because this one's 51, this one adds up to 54, this one adds up to 51, 54, 33, and 54. So if it's 51, 39 and 51 is 90. If it's 36, 36 and 54 is 90. In the case of the square root of 2 or Fibonacci numbers, which is 27, 27 and 33 is 60, and 27 and 33 is 60 again. So there is a relationship, and I'm just pointing that out. What exactly that relationship means? Well, what my belief is that all of these universal numbers, they're going to fall under the umbrella of the universal number, which I referred to yesterday as the father of all universal numbers. So what happens, well, today what I want to do is I want to show a relationship between the universal unique number e, the natural logarithm e, and the code. So when you see all these numbers, it's very difficult to make a correlation. I tried, but I was just going in the wrong direction. I didn't realize it. But anyway, I came across this pyramid-looking structure, and what it is the numbers 1 through 25, and it gives you the value of the natural logarithm against each of these numbers in sequence 1, 2, 3, 4, 5 through 25. And what I found, and it was not to my great surprise, as a matter of fact, when I saw this, I knew it was going to come out this way, but I had to do the arithmetic anyway, and I did it, to 24. I'm just showing you the first 12, but what you do is you come across the sequence again, 2, 4, 8, 7, 5, 1. 2, 4, 8, 7, 5, 1. So if you are so inclined, you can do it yourself, but as it turns out, the number is not as irrational as it appears. It's literally a repeating sequence of the 2, 4, 8, 7, 5, 1 code that's found in the 3, 6, 9 code, because 2, 4, 8, 7, 5, 1 is the 3, 6, 9 code, and I clearly have demonstrated that over and over, and I don't want to repeat myself incessantly. Now, yesterday I was showing the relationship between the numbers, or the difference between the numbers. For instance, this row going down, 3, 7, 6, 4, 9, 1. Or over here, 6, 7, 6. No, it's not that. 6, 7, 3, 4, 9, 1. So over here it's 3, 7, 6, 4, 9, 1. Here it's 6, 7, 3, 4, 9, 1. In any case, if you take the difference between any of these lines going down across another line going down, you're always going to come up with a derivation of the code, because it's perfect. Okay, so then what I did was I made another new one, and basically what it is, it's the difference between these numbers, and through that I just created the new one. And if you keep on doing that, you're going to come to some very interesting results, and I will cover that in an upcoming lesson. But basically what you get here is you get the code again, 376491369 147. 512487, well, that's 248751. 714714, that appears in the original code. 979491, well, it's 999147. Just the codes reappearing in their appropriate places. So, there's something to be learned from that. Okay, one thing that's interesting about this one is this fact. Okay, so what we have here is, let's add numbers. 3 and 5 are 8, 7 and 9 is 7, 2 and 4 is 6, 6 and 8 is 5, 1 and 3 is 4, and 5 and 7 is 3. So basically, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you may not see that. Let's just do it. 8, 7, 6, 5, 4, 1 and 3, now it's 1 and 3, 4, now it's 5 and 7, 3, now it's 9 and 2, 2, now it's 4 and 6, 1. So 9, 8, 7, 6, 5, 4, 3, 2, 1. We're all familiar with those numbers, right? And so basically the 1, 2, 3, 4, 5, 6, 7, 8, 9 reappears. Once again, you can continue to do that by taking the difference between these numbers now and creating the next schematics, the next matrix, going on to the next matrix, to the next matrix, to the next matrix, and I encourage you to do that because you will come to some very interesting results and you will learn something about this whole thing that I have learned. So since I called it math today, I'm just going to try and stick to the math part, and that's what I've done. So what I did today was I clarified or corrected myself from my comment yesterday that Eulers number and Bernoulli's number are both the same when they're related, but they're not the same. That's Eulers number. And Euler's number is also embedded in the code, and I hope I've demonstrated that for you today. And I will not make any comments, but I do want to kind of, when I came across this code, I understood something. I'm challenging some universal truths, but there are universal truths or things that we in the world consider universal truths that in fact are really not universal truths. And I think part of, my end of the bargain from getting this from creation, from the universe, being gifted to me, is that I have to be fearless and I have to just continue to tell the truth to the best of my ability, and the truth will set us free. Sometimes the truth is not really nice to hear because it shatters some of our belief systems. It's okay. Do not fear the truth. This is Paul Whittekind. Peace and happiness to the world, and I'm signing out.